Alright, Made Up of Wires is back, decompiling Castlevania Symphony of the Night. If you're not familiar with the Castlevania Symphony of the Night decompilation project, you can go to SOTN.z.dev, where you'll find progress on various parts of Castlevania Symphony of the Night that we're working on decompiling. I always start out going through a few of them, and as always, there's still one function remaining with the main game engine. Let's take a look at that today and see if there's anything obvious where we can make progress there. This is a function. Lately we've been doing weapons. Oh, I need to update my weapon counter. Of course. Yesterday we finished the last function in the punching weapons in Weapon 0, meaning we have 3 weapons remaining, 3 weapon functions remaining to go. 2 of those are in Weapon 30, and 1 I believe is in Weapon 17. Yeah, so entity weapon attack for for Weapon 17, as well as 2 of the support functions in Weapon 30. I am going to look at what Weapon 17 is offhand to see if that's interesting enough to look at today. But I think we'll look at this last remaining game engine function. So this is the pentagram and bat pentagram Weapon 17. We might go back and look at that, but let's look at that game engine function first. So when we look at that, it's going to be a little different from some of the other weapon functions that I've been working on the past couple of weeks. This particular function does not have a PSP variant that we can look at. I don't believe it has a Xbox 360 variant either, but we can kind of skim through that and see if there's any constants that we can reference to find the version there as well. Just giving a quick overview of some of the progress. So we have that one function we'll look at in the main game engine. The Richter program is finished, as it has been for about a month now. We had been working on weapons. There's 3 weapon functions remaining. The 3 remaining are in various states of completion. And then several of the stages, as well as the familiar. And we can look at the familiar too. That's been started. This is the bat familiar. I haven't looked at that. I don't think at all. So I'm not really familiar with what's in that space or what the PSP might be able to tell us there either. The source code for the project is in GitHub, and you can go to ZYnamo's SOTN Decomp repo, where you'll find everything that has been decompiled to this point, as well as a lot of the tooling that has been built to support the project. And you'll find a link to the Discord server there, where we're chatting about the project, chatting about decompilation, about anything related to the PlayStation toolchain, and specifically related to Symphony of the Night. In this case, ROM hacking, ports to other platforms. I was going through comments on YouTube yesterday. There definitely is a lot of interest in a native PC port. I'm somewhat surprised. I made some comments there too. I've done some just minimal browsing around the iOS and Android versions of the game, and there's nothing in those that would seemingly prevent them from being ported to PC or Mac OS. The iOS version boots and gets into the license modal screen, the way that the APIs differ. It's not a game made for Mac OS, so when you're running iOS applications in Mac OS, sometimes things don't work out, and they've not approved it for Mac OS or anything, but the way the screen is drawn there is broken, and you can't get past that license acceptance screen. So not perfect. Curious why. Those versions of the game are emulating the PSP version of the game, however, so even if even if they did release those for PC, they would be emulated ports like the Requiem version of the game. Along the way, if people have any questions, comments, or anything that they would like to see, I'm happy to answer those questions along the way or address the comments. Yeah, I really like to do what I can to help people either get involved in this scene, understand more about what's going on with decompilation, or just talk about the game. It's a game I think that we all enjoy, otherwise we wouldn't be so passionate about trying to get it decompiled. So when we are looking for functions that need to be decompiled and that are remaining, unfortunately, I'm going to have to fix OBS here. Give me 1 second. Occasionally OBS stops tracking my windows, and I'm not sure why it does that. It'll just take a second though to fix that. Yeah, and that looks fine now. Alright, so these are the 3 remaining weapon functions. We'll get into those if there's not much that's interesting to look at in this last DRA function. So if we open up this file, the way that these files are created originally is by using a tool called Splat64. Splat64 uses various attributes of the original game files. Excuse me, I'm not typing correctly. It uses attributes of the original game files to find, in this case, PlayStation files are ELF binaries. It's looking for offsets in those files that represent data, read-only data, text or code, and SBSS or BSS, which is a bunch of zeros. So it'll look through the files to try to find those delineations, and then within the text section it will look for markers that indicate where function boundaries are. And once it finds those, it will generate C files, which include macros in them that look like this, include assembly, which it has extracted into another directory, which contains that assembly code. More likely than not, this function actually has been started by somebody else. And so I want to look and first see what has been done here and how far along people are. So it looks like there's a couple, I actually have a couple scratches open here. It's been a while since I've looked at this. So we have one scratch by an anon, that's about 89%. Mine, I was at 86%. Oh, this is actually very short. Oh no, sorry. This, what am I looking at here? Is it really just this A20 function? Oh, there's a bunch in here. That's got it. Sorry, trying to reread what this is. So these look like they're all forked from each other, and so we have different functions in various states. And this, I mean, going back, Zyynamo created this scratch a year ago, so it's definitely not going to be a straightforward decompilation. We've had people working on this in various states for over a year without success to this point yet. It does look like somebody went through and created a pretty nice documentation of the assembly. This looks like something when I was handwriting assembly about 20 years ago, no, more than 20 years ago in college, what I might have written alongside my assembly. And I just want to scroll through and see like where the big areas are. So down below we have some register swaps. that's not anything. Oh, I'm sorry to anybody who is watching. I forget that that OBS does this to me. Give me 1 second to fix OBS. There we go. Sorry, I was I was narrating this this function in Scratch, or sorry, in decomp.me, and you can see it along the way. Howdy Orkim. I'm not sure if that's the correct pronunciation, but good to have you. I'm always happy to have people in the chat. So kind of going back and reiterating what I was saying before, I'm going to look at the target assembly here versus the assembly that this C code is producing, and follow this gutter down the middle to see where the differences are. When I see just register swaps, that could be something that I could take action on. But in this case, this particular register is being used the same way on both sides. So likely that code is correct. There may be a variable swap somewhere else, but more likely than not, there's some structural issue with the code above or below, possibly, where the compiler has decided to allocate those registers differently. And so it's not something that we can fix directly. So I'm going to go up here where we do see different types of differences. So there's shifts up here, which aren't appearing in the original. There's instruction differences that aren't appearing in the original. And this likely is where the bulk of the difference between the two implementations is. And I'm hoping that, this is right near the top as well, I'm hoping that when those are resolved, the registers will end up working out, and those won't have to be addressed by themselves. So I did mention earlier that this is a little different from many of the other functions that I have been working on recently. With the weapon functions, they all follow basically the same pattern. You're taking an entity in as the first argument of the function, and then you're basically implementing the state machine for that entity. Weapons, in the case of weapons, obviously. And that state machine includes how to draw the weapon, what effects that weapon has on other entities that it may collide with, and things like that. Whereas this looks to be related to font rendering. And so the signature to this function is very different, pretty straightforward. Taking a character and a kind, we can kind of dive into what that kind might be. And then likely loading that or constructing those glyphs dynamically. So let's start down here and look at the for loop. So we're targeting, or we're writing code that's ultimately being compiled by a very old version of GCC with standard optimization. And to be able to map our C code to assembly, we're not going to have necessarily a straightforward translation. So here we're setting up a for loop. You'd expect instructions for setting a register to 0, maybe doing the branching logic for checking that against whatever limit is set here, doing the increment on that variable, or putting that increment much further down. In our case here, we're also an add instruction, adding the constant for to a particular register is getting thrown in, and that's because when the compiler generates this, it has determined that somewhere along the way, related to each iteration of this loop, it's going to be moving likely a pointer, a 32-bit, a pointer to 32-bit values over by 1. And that's likely caused by one of these two, or possibly this here. And so it doesn't have to do with this for loop line, even though the debug information puts those things together. So we have to figure out where that add is coming from here, and if that add exists in the original code, why is that happening out of order? So I actually don't see an obvious analog. So I'm going to skip this for now. There are some shifts down here which may or may not be related. We'll come back to those and kind of work this out a little bit. What I'd like to do is just go through and start finding where some of these issues are. So there are two add instructions down here, and so these are happening. This add for T8 and T5 is happening out of order. It is, those are being used equivalently, so we have a register swap, which isn't a huge deal. And then it looks like this AND is also happening out of order. So what's curious to me is where this V0 is being incremented. Yeah. So often, just being familiar with the code base, there are a lot of these cases where dereferences happen at the same time as those values are being pulled. So dereferencing and incrementing at the same time. That first one definitely seemed to improve at least register selection. I'm watching the assembly change and kind of keeping an eye on how different the two things are. I'm not going to use that as an absolute determination of whether this change is correct or not, but rather just kind of a guideline to see if I'm going the right way or not. Overall, this does end up being further away, but I'm not terribly concerned about that, and so I'm going to stick with that that increment. All right, so then we're missing some of these additions. So we're taking the value 2, adding it to this V1 value, which we're sitting on 164. So I think that's what is being attempted here. However, I don't... think that that is necessarily correct. We have a significant amount of out-of-order execution down here. So this originally was somebody else's code, and they've translated this from likely the decompiled version. I'm going to swap over to look at that just to get a sense of what the decompiler thought. Sometimes looking at the GCC assembly isn't necessarily straightforward. So this is our loop here that the decompiler had generated. This can be difficult to parse as well because we have a bunch of just mechanically named variables. So many of these appear to have been executed closer above here. So everything that's necessary for this computation has already been calculated at this point. There are some we are still missing these values here. In all these cases, I want to make sure that we're operating on, I mean, these appear to be, T is a 32-bit value. Okay, that's reasonable. And our alphabetical variables are 16-bit. I just want to see what the, why some of these masks and shifts might be being done. So there is this addition that I would like to try to resolve. So T2, T1, ultimately these are seemingly getting stored into this H variable. So I'm going to try a few things, not particularly scientifically, but just to try to introduce some instructions in a way that will give me a few more guide stones here. Oops. So it does look like this shift left that's happening up here. Maybe happening above. And we may be able to reason about what, do we have a sense of what var T1 is? That could help. Let's look at what this looks like. Oh, this is, we're populating this in memory, so nothing that's currently stored there is going to make a huge difference. Let's look at what other documentation we've been left with. So here at this offset, the calculations that we have currently in the code are quite a bit different from these. And so possibly these are just missing from this larger operation. One thing I would possibly like to do with this there are still I'm not too concerned what the variables are at the moment, primarily just looking at are we introducing operations that are similar to what's happening. So we're setting basically nibbles through the 16-bit value. So we're setting offset 0, offset 4. Each of these I would expect to be masked as well, but they're not being masked. And we see the mask here, but not necessarily in the code that we've generated. Let's see, 173. Let's try this one. Oh, that's that mask is for a byte, however. Yeah, unfortunately, I don't think I'm going to make much progress on this at the moment, and I might come back and look at this offline and maybe bring it back next week when there's more that I understand about this function. A lot of times I can drop into these cold and make some progress, but in this case, it's just not an area that I'm overly familiar with. Speaking of familiars, let's take a look at those functions and see what's remaining there. What is our familiar path? Servant. So we have two functions left for the bat familiar. I'm going to go back over to decomp.me and see if we can find either of those and see what might be happening there. I'm not sure if this is the same one or if this was pulled from something else, but it likely is. We might be able to do some work here. So this was something I started about a month ago. I'm going to look for a PlayStation version of this function as well. Okay, so Zdynamo has does have a completed version of this that is matching for PlayStation. So I'm not going to spend any time on this, and we'll probably go back on Discord and see if he needs any help getting that committed. And the other function. So we do have PSP and PlayStation versions of these. So Sozu was working on these. These look like they are actually complete as well. So when we're working in decomp.me, we will see some differences. So in this case, there's 260 edits necessary to get from the current version versus the target version, but many of those edits are immediate values where the symbol is just slightly different. So we're using a tile map array reference with some offset, whereas the original just has a symbol that we've given that at a particular memory address. And so as long as the only difference there is symbols, I'm not terribly concerned there. So it looks like familiars actually could be completed from a code perspective, which is great. So hopefully I'll poke people in the next couple days and see if we can get those checked in and get that work done as well. The things that I've been doing lately definitely seem more project managey than necessarily decompiling, and that's kind of a nice place to be sometimes when the technology and the community are working as they should be. Okay, so let's go back to weapons then. We'll continue on that. So we have entity weapon attack for weapon 17 remaining. We're at about an 83% match. I want to see if I have a PSP version of this already. I do, which is great. Looks like Max has been working on this as well. You can hear my modem in the background. So he's a little further along, but this is a fork, it looks like, from... my fork is from Josh. So we're gonna start there. I won't base this on Max's yet. And then let's see, we have the PSP version. I think we'll start. The PSP version's not compiling though, which is okay. I just want to see the family there. No, there's nothing there. So there's some values here that the PSP version of the game uses the MetroWorks compiler versus the PlayStation version using the PlayStation compiler. And to get a baseline decompilation, I find that the GCC compiler is usually easier to start with. So getting the basic structure of the program. And then I'll take that over to the PlayStation Portable MetroWorks compiler and work out some of the details that are more difficult when working just with optimized GCC. So looking at the warnings that are remaining, there's a bunch of issues around arguments to this rotate average nclip function. And working out these variables may help us get a little bit closer. So let's look at the arguments there. So we have a bunch of pointers to vectors, and I see some pointer arithmetic that the decompiler will produce things like this. Usually when there's pointer arithmetic involved, it's we're working with an array, and should be accessing this as an array instead, and most of the time the instructions fall out as expected. There's nothing wrong with doing the pointer arithmetic that way. In general, though, it seems like that's not how the original code was written, and when we're trying to get back to like a bit perfect recompilation, we need to try to do things in a way that's similar to what was originally done. We don't know exactly what was originally done, but we can make our best effort based on what the compiler does. Okay, so we have a series of vectors, vector pointers. These offsets are based on the size of that vector, which is 8 bytes. If we have an array of those vectors, or even if we're just doing the pointer arithmetic, if this temp s3 is a pointer to vectors, this is going to be offsetting by 8 vectors as opposed to looking at the next vector. And so that likely is incorrect. So just changing the pointer arithmetic doesn't get us any closer. So let's look at that. How that's compiling down here, and see. This is one of the reasons as well, though. You don't necessarily use this number to decide if you're getting better or worse. If there's things that appear obviously incorrect, they likely are. In some cases, they're not. So if we're really taking 8 vectors away, in this case, maybe we have a structure or something else that we're should be looking at, or maybe these are 3 separate arrays at different offsets in memory, and we should be treating them like that instead. So let's look at that. So, and that can be tricky with the way the decompiler works. We're taking a reference here to this particular offset in memory, but if these things are relatively close and the compiler determines that it can do the math for 3 different vectors in a straightforward way, it's just going to take that pointer out once and just do the pointer math, so it doesn't have to keep dereferencing or building up pointers in registers. I'm going to go over here and look at what this data looks like. Earlier this week, there was a lot of discussion. So when modders or the randomizer community are looking at this, oh, this is not fun, unfortunately. This is in the SPSS section. And SPSS is just zeros, so it's not gonna. We may be able to see if the splat, when it extracted this, if it determined that there's different boundaries here, we might be able to figure something out that way. I'm going to also find where the S vector structure is, so we can get an idea of what the size of that is. When modders or the randomizer community comes in, a lot of times they're working with offsets that are based on where the file is in an ISO or in a bin of a bin queue pair. Whereas when we're looking at it, we're looking at where are these addresses in memory, because each of the files for like weapons or stages or things like that, they're loaded at specific memory offsets when the game loads them, and the game will say all stages start at such and such a memory location, and we're going to take that file and just basically stream all the bits from that file at that memory location. And that's what happens when you're going in the transition rooms, for example, when the stages reload, or in this case when you're switching weapons. That overlay gets written to memory at these offsets, and so that's what we're interested in is the runtime memory offsets. Other groups that are working on modifications for this and other PlayStation games, they talk about things sometimes in file offsets, and sometimes they talk about them in disk offsets. And so we kind of need to think in a translation between all of those things. At what particular disk offset does it result in this file, and then in that file, what is the file offset? And when that file gets loaded into memory, then what is the final address that's going to be loaded in memory? All right, so and then kind of looking at our data on this side, that's what the first two lines are. So this is our offset in the weapon 0 file, and then this is our offset where it would be loaded in memory, were it to be loaded in memory. Okay, so going back, I was looking at how big is a vector? And this is actually somewhat interesting and not something that I expected. So an S vector is XYZ value. So this is if you think back to geometry, a vector is basically a line in 3 dimensions with some magnitude. And so that's what we have here. And so these are 8 16-bit values. Sorry, 4 16-bit values. So we have 8 bytes. Going back, so that was my suspicion here, was that we were adding 8 bytes. So let's look at the assembly. What I wanted to do was just ensure that that's what was happening. What this math says is not that we're adding 8 bytes, but we're adding 8 of these short vectors. 255, let me... 254. When we're looking at how these things are being loaded as arguments, we're looking at the A registers. So the value that's stored in S1 is going to be put into A0, which is this first argument, down through A8, because we have 9 arguments to this function. So this T3, why is T3 in this mix? I see. So T3 is our offset of the stack pointer. It is these values, but where is this being pulled in as arguments? So I see the first 3 arguments. Maybe that is... We have more argument registers than just the 3. It looks like maybe after those, 4. After 4 argument registers, the rest of the values are, looks like they're stored to the stack. We don't see many functions with this many arguments, so what the calling convention is not something I'm familiar with, but it does look like these are... It's not just the stack, though. These are getting stored into other registers as well. Ultimately, this is why things like this haven't been solved, is the esoterica of mid-90s GCC, along with MIPS, is not something that is used a lot anymore. Unfortunately, I'm going to come back to that line. I was hoping that I could reason that out, but I'm struggling. We should be able to deal with this, though. So here we have a we're taking a reference to this particular offset, which looks like a array of 100 S vectors. The decompiler will do this a lot, but it's much nicer to write this as array access instead of pointer addition, in my opinion. It should produce the same instructions with optimized GCC, but it actually is a little... Is it better or worse? Sorry, I'm not following the numbers. Yeah, so it's a little more accurate. There is so this value is being shifted, and I think that's again because when we're doing pointer arithmetic or array access, the value here needs to be in terms of the size of whatever structure this is. So when we see a shift left by 3, that's the same as a multiply by 8, which is how big this S vector is, which is then how the array is indexed in memory. However, because that shift isn't being done in the original, it looks more like this is being treated as an array of bytes, just single byte entries. That may be due to this offset being calculated some other way. In this case, so when the compiler comes in, it may have optimized this out to do this differently. So one thing I see though here is I'm trying to look at where this is being tracked and why it's being tracked that way. So it is a value that ends up back on the stack. as opposed to being in a register. We are introduce something that's not compiling. Let's actually look at what happens if we replace that with var_j. Yeah, so not perfect. We still have this shift that probably isn't necessary. And actually that affected quite a bit of other instructions. I'm going to look at the decompiler and see what it's doing there. So yeah, a lot of this code just came from what the decompiler was doing, as opposed to maybe what we should be going based on. This is probably a good time actually to go over to the PSP version and see if we can make any progress there, because I'm not seeing many obvious things on the PlayStation side. Luigi's evil. I'm not sure I agree with your username, but you're very welcome. What's wrong with Luigi? I think ever since Mario 2, the US version of Mario 2, I've kind of enjoyed Luigi as a character. Maybe that's not the Luigi you're talking about. Maybe there's another Luigi that I'm not aware of who truly is evil, in which case I agree completely. Okay, so on the PSP side, we have to go through and there's liberties that GCC will allow you to take with your C code that MetroWorks is not having any of. Sometimes fixing, so there's a lot of undefined behavior that GCC is just extremely pragmatic, and they wanted to be the compiler that everybody uses. So there are cases like this where GCC's like, yeah, dereference that, I don't care, I'll shift it over by 16 bits. And MetroWorks is like, that's a struct. I don't know what shifting a struct by 16 bits means. Fix that. So let's do that. Let's fix it. So we can see what var_s3 is. So it's an S vector. So GCC likely says, I'll just take the 16-bit value at that address. We need to tell MetroWorks what we mean here. Oh, and same thing with here. Down here on 168, when we have negative offsets in arrays, that means that GCC has generated negative offsets, but we don't get to. That's not what we get to do. We have to figure out what offset we should have originally used. In this case, it looks like it may be this B3F4 offset, and use that, and then GCC will come in when it does its optimization and do the right thing. Let's see if we can actually, we can get a decompile here. Sometimes the way that you have to upload functions with case statements in them, I failed to do that correctly for the PSP version. There's some idiosyncrasies there that I don't always get right, and I don't care because I'm just copying PlayStation code over and I don't need those offsets. But in this case, I did the right thing. This is going to give us something that should be easier to deal with. So I'm looking for case 1 in here. This is happening out of order. So we see something much simpler here on the PSP version. So this is our loop setup. That seems fine the way that it is, but we're only taking one, I guess 2 pointer offsets, this var s0 and then var s1, and it looks like we're just copying data from one to the other after shifting it. So let's assume that these are correct. The offset by 8 is meaning we're going to the next, if this is a S vector, it may not be an S vector. We're going to the next element in that array because it's 8 bytes further over. Here we're loading 32-bit values and storing the 32-bit values, so it's looking to me like S vector was the wrong data type. There are S vectors used throughout, but I'm not sure that this is correct. Get back to case 1. I just want to see what. Yeah, so this likely is an S vector based on the offsets. I want to look at var s1. Oops. It says that it is, but what it's loading do not look like S vector offsets. So we'll assume that this is an array of S vectors, and that we're kind of populating out so many values in this array. That should be fine. It should generate equivalent assembly, but we do have to go through and clean these up. A lot of this logic is just bizarre. This seems very suspect, but until I know like how this is being used, it may be fine. The PSP version gives us a more linear version of how this will be compiled, and so when we look at the decompilation there, we should be able to this is odd. We should be able to see the correct order of the instructions, and then when we take it back over to GCC, that might flip the order around, which is why we have a different order during decompilation there, but that's just because that's how it's ultimately been optimized. These really seem like all these store 32s, but now there's some 16s down here. Wild. All right, so I'm gonna continue on, assuming that I'm headed down the right path, and if not, we can correct later. Offset C is going to be VZ of 1. So we have, these are each 8, so we're 4 away, and then Z of that. There's this assignment that was happening in the original. It looks like this is supposed to be down below. I don't see where this value is ever being set, so it looks like there's a mistake there. It's very possible that that I am headed down the wrong path, but I'm not terribly concerned. I would like to get this compiling, and then we can kind of determine whether or not that's actually the case. And so, since we do want to get there first, I am just going to populate offsets here, and then I'll come back and we'll fix those up. I'm not too concerned what these values end up being. So Vars 5 is unneeded because we should be looking here. But we will have to increment this variable along the way. Let's go back and see what else we're missing. So there's still some things on line 168 that are not clear yet. Hey, Tux Can Play. Good to have you back. So 192, just cleaning up one of the weapon functions that exists, trying to determine what this might be. Okay, so that section compiles, which is all I can hope for at the moment. Some of these I'm just going to put placeholders in because I don't want to spend too much time on them. I want to get something that is compiling to get a general idea of how similar this is on the PSP side, or if it's working yet or not. This looks like a similar issue here, where some math is being done based on the values that are here, but oh, this is not a structure. I see. So we're was var a2. Var a2 is s vector. Many of these things, as I mentioned before, it's not clear if these are right or not. So I am just going to be putting placeholders here that will get this to compile, but may or may not be wrong. Based on what I'm seeing here, it does look like these are structures that maybe they're not defined as structures, but they are, it is structured data that isn't necessarily just a straight array. So we only have one left, which is nice. Many of these look like they have the same structure, which is nice as well, the same control flow. So we should be able to go through, and once we solve one, go back and repeat the same process. So on line 233, is this saying that temp S2 is a S16? And so let's just treat it like that. We'll cast it for now, and we should get a compilation now. All right, 29%, not great. That's okay. The PSP version, when it compiles, part of being not optimized is that logic that's the same that GCC or even the MetroWorks optimizer would come in and kind of say, recognize patterns that the code is written differently, but you know, these are multiplying by 2, so I'm going to make a shift by 1. The optimizer comes in and kind of makes all these things uniform, but we're compiling without optimization, so whatever the code is as written, that's what we're going to get over here. And so the initial passes usually are much further off. But we do have something, and we can kind of see where the bad parts are, and where we can focus, and if there's anything that's straightforward to start fixing. Let's run from the top to the bottom. And just see if there's anything straightforward that can be done here. So one of the first things I see here, likely one of the GCC optimizations as well, that somebody was trying to leverage, is that this self argument, which is the first argument to these functions, these are written I spent a lot of time doing Rust in the past week, and Rust uses self as its this argument or whatever the current object being is. That's how a lot of these functions are written as well. And sometimes GCC will take that argument register and want to reuse that for something else, and so it'll either throw that value on the stack or move it to a different register or other things like that. And so that's why these assignments sometimes come in, but the assignments likely aren't there in the code. So we should find all the others and replace them with self. There's probably some lost analogy that I can make there, but I can't think of one. Any Lost fans in chat? The first 2.5, maybe 3 seasons were good of Lost, and then it fell off a cliff. Maybe Lost is something that just boomers watched and nobody remembers. In the mid to late 2000s, it was quite the deal. All right, so that assignment is gone. Immediate values, register values, there's nothing we can do about that yet. So we're storing a byte here. where this is one of the great things about compiling the PSP version. This looks like yeah, that's what we're doing on this project. Actually, that's pretty much what the permuter looks like. You type in some things into the permuter, and then everything flips around. Let's let's get the. Oh no, I fixed that one, and so I don't have a. Let's get this one. I can't do that at the moment. I had the permuter going at one point yesterday, working on something. And I didn't push the button, and that universe is now destroyed. All right, so in our version, MetroWorks helpfully tells us that we're storing a byte, but the original one was storing a half word, which is a 16-bit value. So virus1 is not a byte as was specified or declared. It is going to be a 16-bit value. So moving on, oddly, oh no, we don't have to worry about that yet. So we have stack offset values that are different. We have registers that are different. It's not worth spending time on either of those. Let's try to determine what virus1 is, because if we figure that out, we can give it a nice name. Virus1 looks like it is our one of two V values. And so let's call virus1 V offset. It's not often where we have a separate variable for that. U and V are X and Y for the texture map. So instead of having primitives, so a primitive is a quad, we have 4 XY coordinates, XYZ coordinates? They must be XYZ, because we're building in 3D space. So we have XYZ coordinates for our quads, and then as part of that quad too, we have what texture we want to map onto that quad, and the offset into that texture is the U and V value. So at each corner, just like we have the X and Y values, we're pinning part of that texture to those values as well. So that feels good, getting a variable named. I find that part to be one of the more helpful things when going through these. As things start getting named, it's easier to reason about what the logic is doing. So here is this value is being set on one side and not the other, and it looks like it was just part of this logic. And this virus0 is also going to be a 16-bit value. And let's see what that one does. So this is our U offset. Nice. So very quickly, we now have two things. This is, we'll get there in a little bit. My guess is that this is unnecessary. These casts, or these masks, are happening because the values are being treated as bytes. And so we'll have to see why. My guess is that that's kind of implicitly happening rather than an explicit operation that's being stored into a separate variable. Going back up, and along the way we can kind of, there's definitely things that I messed up down below, but we can copy this back over to the PlayStation side as well and see if this is improving or moving further away. So I'm going to skip past all these register and stack differences. it's not something that's worth focusing on early on. In this case, this is not likely a bug. So this is when we are in the first stage of a weapon animation. So all these functions basically are state machines, and so we have a step associated with the entity, and at different steps we're going to perform different logic. And typically, case 0, which is the first step, we're going to allocate the primitives that are necessary. In this case, we're allocating 25 primitives, but then our loop is only going through 24. But what we should see at the end, and we don't, or do we? Yes, we do. Sorry, I was looking at the wrong loop. So we go through 24 times here, but then we do a bunch of work on the last one that's different from all the previous ones. So while the comment is helpful that it pointed that out, that is the correct value. And so we could do one of two things. We can we could set our primitive count constant. We could set that to 19, or we could set it to 18, and then we have to determine, are we going to replace these all with primitive count -1, or are we going to make the primitive count 18 and then do a +1 where we need the extra one in there. To me, this is more straightforward, but that's just an opinion. Obviously, it's much noisier, but I think it going back through this code and reading it later, it would become obvious that the way the loop runs, it's intentionally skipping one of the primitives that was created. And one thing I did up here, I said the right thing earlier. I put the hex value as a decimal instead of the hex value. That doesn't get us anywhere closer to a match. It's simply for being able to keep track of this and helping understand what's going on. So here there's a move. We're moving the result of this allocation into a separate register. This V0 to V1. That's also not something that we can necessarily address directly, so it'll be skipped. As variables are determined, this should work out, and I'm not going to stress. So on the PlayStation side, you might look at that and say, oh, I might be able to reason about why that move is happening. Maybe I'm doing an assignment or something like that that shouldn't be done. On the PSP side, I've found that the moves typically indicate I have incorrect variables, either too many or too few, and as I figure that out, those instructions will start to align. Same thing down here, not concerned about that. So we have a lot of stuff that's noise that we need to ignore. Just knowing that is half the battle. So I'm kind of going through and, again, ignoring the moves, ignoring the immediate differences, ignoring register differences. What I'm interested in is this first one down here, where we are going to have immediate differences here, which are these addresses here, but there's also this offset of 24 that's being stored. And so it looks like these instructions are out of order. Possibly, yeah, that looks right. ext is a union of all of the different structures that different entities may use. And so for weapons, typically it's where you want to use the weapon member of that union. And I just happen to know that the lifetime is the same as timer t. So now these look better. The original is using register S0. We're putting this value onto the stack. This is also something that will fall out and be corrected as we figure out the right variables and types, much like the move. So I want to look here. Here this is loading. The generated variable names for the PSP, these names are based off the offset in memory that these values would be loaded at, and the offsets on the PSP and the PlayStation are going to be different. The way that overlays and memory addressing is set up on the PSP is different from the PlayStation. And the way the MetroWorks compiler builds the objects that are used is different. So we can't rely on those addresses between the two. We kind of need to ignore that they're different. But one thing I notice here is these addresses are very different. So we're looking at 44A4 versus 3EA0. Those aren't really close to each other in memory. They're about, what, hex 600 bytes away from each other. So it's not contiguous by any stretch of the imagination. However, when this was decompiled on the PlayStation side, people who had worked on this earlier put these values as contiguous, which it does not appear to be. I'm going to go over to the PlayStation side and just review what this would have looked like here and see if it's obvious why. So what more than likely happened is there are two variables that are being set for different offsets. However, on the PlayStation side, GCC basically optimized loading one of those addresses out because it may be doing the arithmetic a different way and using the same register then and just doing the arithmetic on the register instead of spending another register on a separate address. I'm trying to think if there's a more straightforward way to look at that. I'm going to look at the decomp for this section of the PSP. So we do need a different address here. What this address is right now, I'm not certain. But while this is doing that decompilation, we can try to find this. I had been having a reasonably good week for decompiling, getting matches. After last week, which was a fairly disastrous week for decompiling. So we kind of go in waves. Today's not the best, but we're having to do some groundwork on the remaining 3 weapon functions, which they're the remaining ones for a reason. All right, So let's look at this. So I'm back here looking at the decompilation before I look at this data. I want to see where this might be. This actually looks like it. Is it coming from the context already? Oh, I must have added that there to get the decomp. So it was assumed that these were S vectors. What is a little odd about them being S vectors, which they could be, they have 4 values, whereas an S vector only has X, Y, Z, and then basically an unused pad value. So I'm not quite convinced that these are S vectors anymore. Let's follow this around and see how it's being used. So that 4th value is being used. So we need something that is oh, actually it's a 5th value that is being used. So I think we're looking at either 16-bit points, so 2 16-bit values, X, Y, or something else. And the decompiler can help us determine what that looks like. So we can change this to a 0.16, and the decompiler will come through and re-decompile that for us, looking at that value as a 0.16. That isn't terribly helpful. I'm kind of looking at this. It just occurred to me. I'm looking at this as if I don't know what any of these things might be, which probably isn't the best perspective to come at it from. Instead, let's look at it as if this is a weapon function instead, and that it's going to be operating similar to other weapon functions. And so one of the first things that many weapon functions do is set various state related to animation. So I'm going to look for that and see if this this could be animation related. Did I don't recall if I looked at this at the beginning of the screen. Oh yeah. So this is pentagram, bat pentagram. Let's look at that as well. This is the main entity weapon attack function. So when you hit the attack button, what do we see on the screen? It's useful to go to find those animations, and oh sweet, what is the likelihood that there are 25 pieces to that pentagram? I'm guessing relatively high. All right, so a lot of times this helps, and in this case, so we don't know for sure yet that this is the animation that's being set up and running But a lot of times that's the simplest explanation. So that's likely what it's doing. So I want to look at this as well. If we set a timer, what is the likelihood that the initial symbol shows up for, I would say, what, 900, 850, 900 milliseconds? Let's see if we can get a stopwatch and time that. It won't be perfect with a stopwatch, but it'll be pretty close. I got 0.68. Oh, that's probably more accurate, because is the timer running at 60 frames a second? So yeah, so a lifetime of 24. Is this?
Sorry, I'm having problems completing your request. Please try again later. If you continue to have issues, please contact support.
So for 24 frames, we're showing that that image, and then we're breaking it apart. That seems likely. So are we? Yes. So we go through, we set up all the primitives, and then we move on to step 2, or case 1. And then we don't actually do any of that work until the timer is expired 24 frames later. So I do believe that that is what is being set up here. There is some additional flashing that's done, but that might be done by some of the other functions. There actually isn't any other functions here. So that's probably done further down after the main switch. Yeah. Based on the time that I have, however, I will have to be ending the stream now, which is unfortunate because we just kind of got into, you know, what is this entity weapon attack actually doing? But we can continue this on. It's unlikely that I'll finish it this weekend. I don't have a lot of time to be decompiling this weekend. I will, just for fun, see if we're any closer or further away. Much further away, and that's because of the pointer work that I did to get it to compile here on the PSP. We'll get it back to something that works on the PlayStation as well. If you want to know more about the SOTN Decompilation project and maybe see code that was actually decompiled, you can go to sotin.z.dev, go over to our GitHub repo where you'll see all the code that's currently in flight, if any, as well as anything that has been checked in already. Sotin.z.dev is a great place to get a general sense of what the progress is on the project as well. Go to the Discord server and come chat with us if you want to help. We're happy to help get people set up, get started. We have people working on Windows, Linux, and we can get you going with what you have. I think there's some people doing code spaces or something like that as well. That would be amazing to me if that's if that's the case. Beyond what I would do. Anyway, go to any of those resources, check it out. I'll be back on Monday with any updates from the weekend and decompiling some more functions. Since we are almost done with weapons, not much more will be happening there on the stream after next week, probably. There has been talk about Marble Gallery being the next stage to decompile. So there might be some stuff there. Otherwise, we can go back to some of the other stage work that hasn't been finished for the stages that are in flight. If you are interested in seeing more, you can go to YouTube. You can check out the replays here. If you want to see what happens next week, please follow, like, chat in chat, comment on YouTube, do those kind of things. That helps just helps me understand what people are interested in, what they want to see. And if there are things specifically that you want covered, or you want to know how a particular part of the game works, I'm happy to do some work offline and bring that back in a future stream with anything that I find along the way. In the past, we've looked at some of the things that the randomizers do, different from the base game, but we can look at all kinds of other things as well. I do think it would be nice to kind of start from the beginning of one of the overlays and just kind of map out what it would take to start a new file within the game. Starting an entirely new game probably is out of scope for a while on the stream. But yeah, that's kind of some of the plans for the not too distant future. Anyway, thanks for watching, and I'll see you on Monday.